Okay, so today's session is related to practical of digital technique and microprocessor. We have completed experiment number 1 and 2. Today we will start with the experiment number 3. So this is understand and verify De Morgan's theorem. As we have already gone through this De Morgan's theorem in theory, we have seen two theorems in this, and so this thing you can read out program outcomes. So these are the program outcomes which are given for this. Then competency and skills achieved will be test the digital systems, logic families and logic gates. Then this is the course outcome. Then you have to check the De Morgan's theorem using ICs. So this is the first theorem which is given in De Morgan's, that is a plus b whole bar is equal to a bar dot b bar, and we have to verify this. Okay. Also there is another theorem known as a dot b whole bar is equals to a bar plus b bar, and in statement it is mentioned like this. It states that the complement of a product is equal to the sum of the complements So complement of A is taken, complement of B is taken, and then we have summed it. So like this, the theoretical statements are also given in this. So from theory point of view, you can take the theorem statements from here also. Okay. Now we need to verify this. So first of all, we'll look at the experiment this first theorem, which is a plus b whole bar is equal to a bar dot b bar. So a plus b whole bar, which is nothing but NOR gate. A bar is a NOT gate, B bar is another NOT gate, and dot product is there, means AND we have to use. So this equation can be written can be shown like this, where we have used OR gate, which has two inputs A and B. The output of that OR gate is applied to the NOT gate, and that will give you the A plus B whole bar. So OR and NOT makes it NOR. This also can be represented like this, where we have first inverted A, then B, and then we have taken product of which, and that will give us A bar dot B bar. So this equation can be implemented like this. So this second circuit is equivalent to the first circuit. Okay. Now similarly, we have this theorem 2, where we have A dot B whole bar is equal to A bar plus B bar, which can be implemented like first of all we are taking A dot B. Okay, so for that we are using AND gate. After that we are taking NOT of that, so AND NOT makes it NAND, which is equivalent to A bar, so NOT of A, B bar, NOT of B, and OR of that, so that will give us A bar plus B bar. Now these things we are going to implement. So first theorem can be implemented like this. All of you can see this diagram. So we are going to verify this. So if you observe, input A and input B are applied to the NOR gate, which will give us the first part of that, which is nothing but this A plus B whole bar. So this NOR gate is going to give us A plus B whole bar, and this A naught will be here, B naught will be here, and of that is going to give me A bar dot B bar. Now we have to verify whether both are same and or not. So we are going to implement it using our Tinkercad. So I'll bring you to the Tinkercad. So this is the Tinkercad which we have used previously. So now if you observe, let's create a new circuit. So how to log into it, that we have seen. You can search for Tinkercad on the Google. That will bring it to all of you to this point. Then you can log in with your Google ID, and then you can create a new circuit. So now I am creating a new circuit. Okay, so this is the first theorem which we are going to implement like this. Let's see. Since network at my side is a bit slow today, because I'm using my mobile net, So we may have to wait for some time. It may take some time. Am I audible to all of you?
Yes, sir.
Yes, sir.
Let me refresh this. Okay. Now, what we need a breadboard first, okay, in order to implement this. So I'm going to take a breadboard. So I'll search breadboard over here. Now in this, I'm going to take a bigger breadboard today because we have to implement two different circuits. So I'm taking bigger breadboard today. This one. Let's keep it like this. Then in this, first of all, we'll make a power supply available. So I'm going to search for power supply. So let's say this is okay. I'll give the name to this breadboard. So next, I'm searching for power supply. So power supply, I'll search. Okay. Let me search power. Just check out that. Okay, power supply is here. I'll bring it to this point. I'll keep it over here. So this is our power supply, and which will have 5-volt power supply. So I can say this is as power supply. Okay, and I'll keep it 5-volt, 5 ampere. Now I have to connect this positive to this positive. So I'll connect it like this. I'll change the color to red because it is a positive. Now if you observe, this is short internally. So I'm going to keep this shorted, so that, and again I'll make it red so that this will be shorted. Now these are shorted. Okay, so positive power supply will come from this to this. Next, we are going to connect this negative to the ground. Okay, and I'll make it black. Then connect this to this, and I'll make it black so that this line will be in short with this. Am I audible to all of you?
Yes,
Yes,
sir.
sir.
Okay, fine. So we have taken power supply, we have connected a breadboard. Next, we have to connect this circuit first. So for that, I need 7402 IC. I hope all of you are able to see this circuit. Is it visible? So 7402 I need NOR gate IC. So what I will do, I will search 7402 over here, 7402, and then this IC I will bring and I'll keep it over. Let us say I'll keep it over here. Okay. After this, if you observe, this 7402 IC, pin number 14 is VCC, pin number 7 is ground. This thing we are aware of. Correct? Previously also we did that. And right now also this is applicable. Pin number, as we have already implemented that, we know that this pin number 7 is ground, pin number 14 is VCC, which needs to be connected first. So this pin number 14, all of you can see power. So this needs to be connected to VCC. I'll give it red color. And pin number 7, this is ground. So this needs to be connected to ground, which I'll keep black. So power supply we have connected. After this, we have to connect pin number 2 to input A, pin number 3 to input B. So what I'm going to do, I'm going to connect a switch, okay, as we have used previously. So switch, and I'm going to use this slide switch. So this I'll bring it over here. Let's say I have connected this. Okay. On one side I'll connect ground, so this I'll connect to ground, and this will be black since it is connected to ground, and this I will connect to VCC and I'll make it red. Okay, and middle terminal will be connected to input, that is pin number 2 as input A. So middle terminal I will connect to pin number 2 as input A. Okay, this switch I will name as A. Okay, as it is a input, but it is connected to pin number 2. After that we have to again connect another input to pin number 3. So for that I'm going to use another slide switch, and that I will connect over here. Okay, this is connected to ground, I'll make it black, and another terminal is connected to VCC, I'll make it red, and then this second input I'll connect to pin number 3. So this 3 is connected to input B. So like this we can connect inputs. After that pin number 1 is connected to register. So I will what I will do, I'll connect I will bring a register, so I'll search for register, so it is already there. So this I will connect over here, to which the input should be connected from pin number what 1. So since this is one output, so pin number 1 to register, pin number 1 to register, and register should be 330 ohm. So I'll make it 330 ohm. Let us say this is R1. Okay, now this register is going to LED, so I'm going to connect this LED here directly. Look, this and this pin is shorted internally because it is on single line, so that's why no need to connect a wire. So anode is connected to resistor and cathode needs to be connected to ground. So this another terminal I'll connect it to ground, and this I'll make black. So like this the first circuit is over, this one. Now we need to make this second circuit. So how to make it? So in order to make it not, I need a 7404 IC. So what I will do, I will search 7404 over here, 7404, and this IC I am going to put it over here. Okay, after that this what I need a 7408 IC. I will search for 7408. This I am going to put it over here. $7408 over here. Okay, now as we are aware that both ICs are having pin number 14 is VCC and pin number 7 is ground. So this pin number 14 we are going to connect VCC. I'll make it red, and pin number 7 I'm going to connect it to ground, and I'm going to make it black. In digital ICs this is common, so that's why we have to do it, and all of you have to keep in mind this thing. This is black. Okay, after that, so we have connected power supply to both the ICs. Now input A should be connected to pin number 1 of this 7404. So this is pin number 1. Okay, this should be connected to input A, and as we know that this is input A and this is input B. Okay, so what I'm going to do, I'm going to connect this input, okay, this another line to pin number 1, okay, as a input. I'll make it some another color, let us say orange. Okay, so this is input A. This also I'll make it orange, so that we will know that this is input A and this is also input A. We have connected to this pin number 1. Then pin number 2 is connected to pin number 1 of 7408. So pin number 2 of 7404 is connected to pin number 1 of 7408. Okay, 7408, which is again not of A. So I'll make it orange again. Okay, after that or we'll keep it green only, not issue, or some another color we can give. Let us say blue. After that, if you observe this pin number, input B is connected to pin number 3 of NOT gate. So what we'll do, we will connect this input B to pin number 3 of NOT gate. This. So this is our, okay, I'll change this color. Some other. Okay, so this is input B, and this is also input B, which is connected to pin number 3 of NOT gate, and pin number 4 output is connected to pin number 2 of AND gate. So this 4 is connected to pin number 2 of AND gate. I'll make it green. Okay, now pin number 3 is connected to register. So I'm going to take a register over here. This register, I'll keep it over here, and pin number 3 is connected to register. So pin number 3 is connected to register, and register is connected to anode of LED. So another LED I will bring, and I will keep it over here. Now this is anode, which is already connected to the register internally, as we have kept it in single column, and this is connected to ground. So this is, let us say, blue. So like this we have made the connection. I hope everything is proper. You can cross verify it. Now the next thing is, what we have to do, we have to apply inputs A and B, and let's see what happens. So this is the connection diagram. Okay, so this is the observation table. A plus B whole bar is equals to A bar dot B bar. What is the input combination? Can anyone tell me? Please reply. What is the input combination?
0 0
0 0. So I'll keep it 0 0, and I will start simulation. Now let's minimize this and let's zoom it so that it will be visible to all of you. Is it visible now?
Yes, sir.
Okay.
Yes, sir.
Is it visible now? So I'm starting simulation. Okay, now if the inputs are 0 and this is also 0, as this is connected to ground, this is also connected to ground, right? And this is connected to input A, and this is connected to, okay, so both the LEDs are having status 1 1, correct? Both the LEDs are on or off. What is the status? Both are on. Okay, both LEDs are on. What I can do, I can stop. Look, what happened? Both the LEDs are off. So this is our basic connection. I'll make a copy of this, and I'll paste it in my circuit also, so that I will have it. After this, I'm going to paste my circuit for my reference purpose. This is what I have connected. Okay. Now my aim is, if I apply input as 0 0, what will be the output? That is the aim. If input is 0 0, what is the output? That we have to see. So if I apply input, if I start simulation, both input are 0 0, both LEDs are on. So what is the voltage? What is the output over here? 1, and here also 1. Yes or no? Am I audible?
Yes, sir.
Yes, sir.
If you want to check out the voltage, that also you can do. How to do it? By connecting a multimeter. If you want, I will show you that also. Okay, give me a minute. So we will take a multimeter. I will connect this to this. Here I will connect another voltmeter over here, and this is connected to ground, black, and this is connected to output of this. So I'll connect over here. Similarly, for this we can connect it to ground, and this we can connect it to this, we can connect over here. This also we can connect at output pin, that is 1. Basically I'm not getting much space over here, due to that I'm okay. I'll change the color, let us say pink. This also I'll make that's pink. Now let's run this and see what happens. So look, when both the inputs are 0 0, over here we are getting what? 1 as output. Let me 1 as output, and voltage is 4.64 volt. So here I can mention by 1 and 4.64 volt. Whereas in this LED is on and voltage is 4.87 volt. 4.87 volt. So this is 4.87 volt. Why this difference is there? This is because of this IC manufacture. Okay, what is happening? Okay, this IC is giving some output, and that the 7408 IC is producing more output voltage. So that's why we are getting more voltage over here. So this is the voltages. Now what is the next combination? Have you noted down this?
Yes, sir.
What is the next combination? Can anyone tell me? What is the next combination? Fast. 0 and 1. All of you are able to see this or not? Let me know. Huh?
Yes, sir.
Why you are not replying? What is the next combination?
0 1.
0 1.
0 1. So you just give me a reply fast so that we will complete it. So this is already 0. We'll make it 1. So this is 1. What is the LED status on both sides?
Off.
Off. And what is the output voltage?
0.
0. Okay. So what we can write down over here?
0.
0 and 0. Both sides, right? Yes or no?
Yes, sir. Yes,
Fine.
sir.
Okay. 1 minute. Okay, what is the next combination over here?
1 0.
1 0. So what we'll do? We'll make it 1. We'll make it 0. Okay. Now what is the status on LEDs?
Off.
Both LED off. And what is the output voltage?
0.
0. Okay. So this is also off, and this is also off. Correct?
Off.
So 0 0. Note it down. Have you noted?
Yes, sir.
Yes or no? 0 0. We are getting both same. Next, what is the next voltage?
1 1.
1 1.
1 1. Okay. So let's make it 1 1. This is already 1. I'll make this also 1. What is the LED status and output voltage?
Off.
Off.
Off, right? So this is 0 0 and 0 volt 0 volt. Correct? Note it down. Have you noted or not?
Noted.
Noted, sir.
Fine. So if you observe this, what you can find is in NOR gate, what is the in NOR gate, what is the what we can say truth table? Truth table is 0 0 1 0 1 0 1 0 0 1 1 0. Hence the not true table is also verified. And also if you observe this as well as this, LHS is equals to RHS. Is it true or not?
True.
True, sir.
So means De Morgan's theorem, first theorem is verified, correct?
Yes, sir.
Yes, sir.
Okay, now we will go to the second theorem. Second theorem is what? A dot B whole bar is equals to A bar plus B bar, which can be implemented like this and this one. Now if you observe, if we replace previous NOR gate with NAND gate and previous OR gate with AND gate with OR gate, the circuit becomes second theorem. So what I'm going to do, I'm stopping this simulation, and instead of 7402 I'm using 7400, and instead of 7408 I'm going to use 7432, and remaining circuit will remains as it is. So let me connect the things. Okay, so 7402 I don't want, instead I want 7400. So what I'm going to do, I'm going to use a search for 7400. Remaining connections will remain as it is. Now I'm not going to do the whole circuit connection because that will just take our time. Okay, so this 7400 I have connected. Now here, instead of this 7408, I'm going to connect 7432. I'm going to connect 7432. We'll cross verify the circuit only, but otherwise. Okay, so I have connected this. Now let's just check out the circuit diagram. So in this first part, input A is connected to pin number 1 of NAND gate 7400. So input A is connected to pin number 1. So this is a bit wrong. So what we'll do, we'll correct it. We'll connect it to pin number 1. Okay. Then input B is connected to pin number 2. Input B is connected to pin number 2. So this is also we are going to correct. So pin number 2 we have connected. Then pin number 3 is connected to register. So this register is connected with pin number. So I'll make it correct. So pin number 3 we are connecting. Okay, so pin number 3 we have connected. We can do one more thing also. We can take it over here, and this connection we can do like this. Then it is visible. So pin number 1 is connected to input A. Pin number 2 is connected to input B. Pin number 3 is taken to the register. Then register is connected to LED and ground. So this connection remains as it is. Fine. Now on this side we'll see input A is connected to pin number 5 of NOT gate. So input A. Okay. So this is our input A is connected to pin number 5 of NOT gate. So what we can do, we can connect it to pin number 5. So this is pin number 5. 1, 2, 3, 4, 5. So this is 5. Okay. Next, this pin number 6 is connected to pin number 1 of 7432. So this we are going to connect pin number 6. Like this also we can connect pin number 6, and this we can like this. Pin number 5 is input, pin number 6 is output, which is connected to pin number 1 of OR gate. Similarly, input B is connected to pin number 13. So input B is connected to pin number 13. 13 is what? 7, 8, 9, 10, 11, 12, 13. So this connection we can connect it over here 13, and then okay. So either you can use that, or this also is fine, because we have to use the NOT gate. That's it. So either you use this, that is also fine. So instead of this NOT gate, we are using this NOT gate, not an issue, which is connected to pin number 2, and then pin number 3 is connected to register. Pin number 3 is connected to register, then LED ground. Is this connection okay for you, or any doubt in this?
No, sir.
No doubts?
No, sir.
No, sir.
Okay. So what we will do now, we are going to verify this. How to verify this? Again, in the same fashion, we will apply 0, 0 first. So we'll start the I'll just take a print screenshot of this and I'll post it in my record. So this is the connection what they have shown, and this is the connection what we have made. After this, we are going to apply input 0 0 start simulation. We have connected this. Now if we do this print screen, yes, okay. So what is the output voltage over here? Give me a minute. There is a small correction. Look what happened. Here we are getting 0 volt. Here we are getting 4.87 volt. But both the LEDs are on. It means this LED multimeter is connected at wrong position. So what we can do, we can stop the simulation and we have to check. Okay, this should be connected to what? This should be connected to pin number 3, which is the output pin. And now we have to. So what I will do, I'll take a printout of this. This is wrong. So I'll delete it and paste new one. Now I'll run the simulation. Now if you observe, you are getting correct output, right? Yes or no?
Yes, sir.
What is the LED status right now?
On.
1 1.
And what is the voltage?
4.64.
4.64 volt. 4.87
4.87 volt.
Right. So what I will do, I will mention it over there. So what we got this at this position. What is the next combination? 0 and 1, right? I'll make this 0 and this 1. Okay. What is the LED status and what is the output voltage?
4.64 volt and 4.87 volt.
And both LEDs are
on.
right? So you can note it down over there. Same we are getting. I'm just copying it and pasting it over here. What is the next combination? 1 0. Okay. So I'll make it 1 and I'll make it 0. What is the output LED status and output voltage?
4.64 volt and 4.87 volt.
So this will be again same. We are getting the same voltage. So I'm just copying this and I'm pasting it over here. Okay, what is the loss combination? 1 1. Okay. So
Sir,
I'll
in
make
LHS.
Okay, let me check. Okay. For 1.11 volt. So what is the output voltage? We'll take the queries. So input is 1 1, output will be 0 0 and 0 0 volt, right?
Yes, sir.
So what the output voltage is? I'll take a print screen of this. Okay, now tell me, what is your query? Please ask. Tell me. Please tell me. Am I audible?
Yes, sir.
What is your query?
Sir, in 0 and 1 volt, LHS 1.61, 4.64 volt and
RHS
RHS
4.87 volt.
Sir, in LHS 0, we are put in 1.
I didn't get your question. Can you please tell me once again? Hello? Please repeat your question. Am I audible? Yes or no? Please reply fast. Am I audible? Yes or no? Okay, then what is the problem? Please tell me, what is your question?
Sir, in second step 0 and 1 volt, the LHS is
0 and
why
1
we
volt.
are put in 1?
Why we have put 1, right? This?
Sir, LHS.
This?
Yes, sir.
Okay, this is the LED status. Means if LED is on, we are putting 1. If LED is 0, we are putting off. Means if LED is off. Okay, what is the status? LED, if it is off, if it is off, we are putting 0. And if LED is on, we are putting 1. Got? So basically this is the LED status.
Yes, sir.
Got it or not?
Got it.
Okay, fine. Now the thing is, if you don't put this also, that is fine. That doesn't matter. This is just a status we are showing. So if you don't put this, doesn't matter. Only we want what is the LED status. So that we have to cross verify whether both side LHS and RHS are same or not. So that we will conclude that this De Morgan's theorem is true or not. Got it?
Yes,
Yes,
sir.
sir. Got it.
So if you don't write this also, doesn't matter. That is just for our identification purpose.
Check verify.
Okay, now if you observe LHS is equals to RHS, it means second theorem, De Morgan's theorem is also true. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So like this. Okay, now there is one question thing, that is resource used. So what you can mention? Give me a minute.
LED light.
So what we can do, I will show you what is the resource used. So I'll stop the simulation. And if you open this, we are getting this much resource used. Okay. So what resources we have used? We can copy this. Okay.
Power
We can
supply.
copy this power supply. So name of resource. This is serial number. So what we can do? So this is power supply. This is power supply. Power supply. Make, we can say Tinkercad, since we are using Tinkercad right now. Tinkercad details. What? 5 volt, 5 comma 5 power supply. 5 power supply means 5 volt 5 ampere power supply. Okay. All of you got this or not?
Yes, sir.
Yes, sir.
Quantity is 1. So like this, you can copy all the things. So what I will do, I will take a snapshot of this, okay, and I will paste it over. Sorry, I will just post it over here so that we can copy it from here to here. Got it?
Yes, sir.
Yes, sir.
And I am going to post this manual afterwards so that you will be able to take a copy of this and you can write down the things. Yes. So here we have completed experiment number 3. Some things are left, and hence we have proved also. Okay. So some of the things which you have to do. Procedure again, whatever practical we have done, from that you can write down the procedure. Make connection as shown in the respective circuit diagram. Then connect 5 volt power supply to pin number 14 and 7 of all ICs. Then apply inputs as shown in observation table. Okay. Note down the output in the observation table. Like that you can write down the things. Resources used, just now we have seen. Precaution followed. make the connections proper, okay, in appropriate manner. This precaution you can say. This observation and calculation just now we have seen result, hence we have verified, okay, or what we can say, the LHS, okay, we have verified first and second De Morgan's theorem, and we found that LHS is equals to RHS. Like that you can write down the results. Interpretation of result, in that you can mention that De Morgan's theorems gives us, okay, the complement of whole term can be converted into separate complement term. That, like that also you can mention. This you have to write by your own. Conclusion, hence De Morgan's first theorem and second theorem is proved. Okay, now this realize XOR gate using NAND gate. So this you will get in book as well as on the net. Okay, just see it and write it down with the help of circuit diagram. Then use De Morgan's theorem to minimize this. So this you have to minimize using De Morgan's theorem. So I think all of you are able to do this, correct? Yes or no?
Yes, sir.
Yes, sir.
Then realize XOR gate using NOR gate. This also you will get in the books as well as net. So you have to draw the circuit diagram for that. Realize XOR gate using NAND gate. So this is repeated question. 1 and 4 are repeated one. Okay. Then 5. Draw 3 input NOR gate using 2 input NOR gate. So this also you can get on the net as well as in the books. So just check out. Then draw logical circuit for following Boolean expression using basic gates. Okay, so what you have to do, you have to simplify this first. After simplification, whatever simplified version you will get, that you have to implement using basic gates. That is AND or NOT. Got it? And hence you have to solve all the questions. Any queries in this, please ask. Any queries?
No, sir.
Okay, so we have completed experiment number 3. Now the next experiment is experiment number 4, that is convert given expression to sum of product form using basic logic gates. Shall we go to the experiment number 4? This is experiment number 4. Okay, so in this, these are the competencies and program outcomes mentioned. You just go through it and read it. So competencies: test the digital circuit, construct combinational logic circuit. Then course outcomes are these two. Practical outcome is this. Okay, so just go through it. Now the circuit. Okay, what is given? Demonstrating an example of 3 inputs where at least 2 outputs of 3 inputs are high. Then output will be 1. Okay, what we have to demonstrate? In 3 inputs. Okay, in 3 inputs, at least 2 out of 3 inputs are high, then output will be 1. That we have to verify. So this thing we have to verify, and this is the expression for that. This is the expression for that. All of you are able to see this? Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
So what is done over here in this combination 0, 0, 0? How many 1 are there? How many 1s are there? Please reply. How many 1s are there?
4.
Huh? In this combination 0, 0, 0, how many 1 are there?
No, sir, 1 nahi hai.
No, sir.
There are-
Only 0 are here.
Okay, so there are no 1. And what is the statement? In the 3 inputs where at least 2 outputs are, okay, at least 2 out of 3 inputs are high, then output will be 1. So here there are no 1, means this condition fails,
See.
right? So that's why we are writing 0 over here. Again, in this combination 0, 0, 1, how many 1 are there?
1,
1.
1. So this condition again
0.
fails, right? Fail or not?
Fail.
Fail. So that's why again we are writing 0. Then in this 0, 1, 0,
0.
0. That's why we are writing 0. Then 0, 1, 1,
1.
1.
1. Why? Because 2 out of 3
Conditions
inputs
are-
are high. That's why 1 is mentioned over here. Got it?
Yes,
Yes,
sir.
sir.
Then 1, 0, 0,
0.
0. Because again only 1 is there. Then 1, 0, 1. 2 1s are there. That's why output is 1. 1 1 0, 2 ones are there, that's why output is 1. 1 1 1, 3 1 are there, that's why output is 1. Got it?
Yes,
Yes,
sir.
Yes, sir.
Now what we have to do, we have to take those terms which are having output equal to 1, because we want to implement it using sum of product. What we want to implement? Sum
Sum of
of product,
product.
right? So sum of product we want to implement, that's why we are taking those terms which are having output 1. So we will leave this, we will leave this, we will leave this, but we will take this one. Now in this we are having 0 1 1, so that's why a bar b c, a bar b c, plus in this a b bar c, a b bar c, in this a b c bar, a b c bar, and the last one a b c plus a b c. So this is the output expression for this given truth table. All of you got this?
Yes, sir.
Okay, so such type of, if in such type of question you have to understand the problem statement first, and accordingly you have to design truth table, and accordingly you have to write down the output expression. Got it?
Yes, sir.
So if you do this, you will be able to implement it. Now we got the expression, we have to implement it, and how we can implement it? That implementation can be done like this. All of you are able to see this diagram?
yes,
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 sir.
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 So what you can observe, here is a AND gate. In AND gate we are applying a bar, b and c bar, which will give us c, which will give us a bar b c. In this second AND gate we are applying a b bar and c, so that we will get a b bar c. In third AND gate we are applying a b and c bar, so that we will get a b c bar. And in the fourth AND gate we are applying a b and c, so that we will get a b c. After that we have to take a sum of that, so we are applying a OR gate, which will add all this, and that will give us output this expression. All of you got this?
Yes,
Yes,
sir.
sir.
Any doubt in this?
No,
No,
sir.
Okay, so what we have to do now, we have to implement that. Okay, this we have to implement. Okay, what they have done now, this complicated circuit they have simplified, and the simplified output is this. Okay, how we have seen this? Give me a minute, I will show you that. The given expression is a bar b c, so output equal to a bar b c, right, plus a b bar c plus a b c bar plus a b c. This is the given expression, right? Yes or no?
yes, sir.
Now if you want to implement this expression, you need 3 input AND gate. How many? 1 2 3 4. 4 3 input AND gate you need, and 1 4 input OR gate you need. So this circuit becomes complex. Now how to simplify this? By simplifying the expression we can do that. How? Equal to, so a bar bc plus, so this I'll copy, and this ABC term, okay, this ABC term I can split it. This we have done previously also, because we know that a plus a equal to a is equal to a. So I can write ABC 3 times also. And if I write down this, what I can do, I will just copy this. Now in this I can do like this. Yes or no? Can I make this? Yes or no?
Yes, sir.
Okay. And in
Yes, sir.
this I can, in these two terms, out of these two terms, and out of these two terms I can take common. Okay, and how I can take common? This is BC in bracket, BC in bracket, it will be A bar plus A. Yes or no? Plus AC into bracket B bar plus B plus, in this I can take AB into bracket C bar plus C. Correct? And A,
Yes,
we
sir.
know that A plus A bar is 1. So that's why we can write down this like BC plus AC plus AB. Correct? So now
Yes, sir.
if you observe this, this is nothing but your this implementation where we have A, B and C, and we are using only 2 input AND gate, 2 input AND gate, 2 input AND gate and 3 input OR gate. So we are getting AB, BC, AC, and that will give us total output. Now if you observe this diagram and previous diagram, which one is simpler one, first or second?
Yes, sir.
Which one is simple, first or second?
Second.
Second one is simpler, right? So that's what we have to verify, whether second means this simplified SOP is going to give us expected output or not, means that truth table, whatever truth table we have mentioned, right? This truth table, whether we are going to get this or not. Okay, whether that truth table is going to give us. This is 6.4. Let me give a minute. I think I have copied the wrong one. Okay, I'll correct that. So whether this truth table is going to give us, means same truth table can be verified with this or not, that we have to verify. Yes or no?
Yes, sir.
Okay, so what we are going to do, we are going to implement this second one. Okay, give me a minute, I'll copy. Okay, I'll correct that later on. So this thing we are going to implement first. Okay, shall we?
Yes, sir.
Okay, so let's implement it using Tinkercad. So what I will do, I'll make another circuit. This I will give a name B. And I'll just go to the back to the Tinkercad and I'll create a new circuit. Okay, in this new circuit, what I'm going to need? I'm going to need AND gates, 2 input AND gate and 3 input OR gate. So what is the IC number of AND gate? Can anyone tell me? What is the IC number of AND gate? Please tell me fast. What is the number of IC AND gate? For AND gate, what is the IC number? Just now we have seen. Can anyone tell me?
7400.
7400.
7400, right?
Yes, sir.
Okay, so in between I have done this activity that I have taken a power supply as well as a breadboard and I am connecting this ground. This is as usual procedure, so that's why I just started this activity. As all of you are now much aware about this, right? Yes or no?
Yes.
Now I am going to take 7400. 7400. So this is called NAND gate. So what IC number you told me? What I want? AND gate. AND
740.
7404.
7404. Huh?
Yes, sir.
Look, quad and
Yes.
7408. So the IC number is 7408 for what? For which
And
IC? And
And
gate. Okay. Another thing we need is OR gate, 3-input OR gate. What is the IC number for OR gate? Or we can do one thing. We can search it over here. OR gate. Look, triple 3-input NOR. OR gate we want.
7432.
Okay, but this is 2-input OR gate. Okay, this is
2-input
2-input OR gate. We want 3-input OR gate. How much? How much?
3-input or
3-input.
3-input OR gate we want. Okay, let's. Okay, I will show you how to do such type of things. Okay, now we need 3-input A, B, and C. Okay, so first of all, we'll connect the power supply of this. So pin number 14 is connected to VCC. Pin number 7 is connected to ground. Is it correct?
Yes,
Yes or no?
Yes, sir.
Yes, sir.
Then again, pin number 14 is connected to VCC. Pin number 7 is connected to ground. Now we need 3-input OR gate, 3 inputs to be connected, A, B, and C. So that's why I'm taking this switch. How many switches I need? 3 switches. 1. Okay, for A, this is A. This one is for A. Another one I need for B. And the third one I need for
C.
C.
So 3 inputs. For 3 inputs, I am taking 3 slide switches. Now I'm going to connect these 3 to grounds as well as VCC. As usual procedure we have to do. Got it? And VCC, another terminal to VCC. All of you are observing this or not?
Observing.
So like this, I have connected one terminal on ground and another terminal on VCC. One on ground, another on VCC. Like this, I have done this. Now the next thing is this A needs to be connected to first input of one input of first AND gate. So what I'm going to do, I'm going to connect this first A input to this is input A, correct?
Yes, sir.
Yes or no?
Yes, sir.
Then A is also connected to input 3. Yes?
Yes, sir.
So A is also connected to input 3.
3.
So what I can do, I can connect this to 3 also. 2, 3, right? So here I can connect. Yes or no? So the same
Yes, sir.
input I am connecting over here. This is connected to this and this is connected to this. Means if I apply input at this will be connected to both. Yes or no?
Yes, sir.
All of you
Yes,
got
sir.
this connection? How I have done
Yes.
this input A I have connected to pin 1 and the same input I have applied to this.
3.
Got it?
Yes, sir.
Yes, sir.
Okay. Now next B. B is connected to in gate 1 as well as gate 2. So B is connected to
1
gate
and
1.
2.
1 and 2.
Okay, this is gate 1. I'll change the color. Let us say yellow. As well as gate 2.
2.
Gate 2 is what? This is gate 2. So I'll connect this to gate 2 also. Gate 2. Correct?
Yes.
Yes or no?
Yes, sir.
Yes, sir.
Then input C is connected to gate 2 as well as gate 3. So input 3 I'm connecting to
Gate 2
gate
and
2
gate
as well as
3.
Gate 3.
gate 3. Gate 3 is this. Let's see. This is gate 3. This is also gate 3, right? And this is gate 2. Okay, this should be here. All of you got how I have connected?
Yes, sir.
Yes, sir.
Any doubt in
Yeah.
this?
No, sir.
Doubt? Any doubts?
No, sir.
No doubts? Okay. So look at the circuit. Input A is connected to gate 1 as well as gate 3. Input A, green wire, is connected to gate 1 as well as gate 3. Input B is connected to gate 1 as well as gate 2. Input B, yellow wala, is connected to gate 1 as well as gate 2. Right? And input C is connected to gate 2, gate 3. Input C, purple, is connected to gate 2 as well
And
as
gate
gate 3.
3.
Both. Okay. Now, the output of this gate 1, gate 2 and gate 3 should be connected to OR gate. Okay, any of the OR inputs you can take. So what I'm going to do, this is output 1, which I'm going to gate 1. So this is input 1. Output of gate 2 is also connected to OR gate. Okay, what I can do, I can make this OR gate into 2 OR gates. How? I can use OR gate. Okay, I can use OR gate. Okay, let me show you how I can do it. Let me open the pen. Let us say I am is it visible now?
Yes, sir. Yes, sir. Visible.
What I need 3 input OR gate like this. I need 3 input OR gate like this. What I can do, let us say this is A, this is B and this is C. What I can do, instead I can use 2 input OR gate. This is 1 OR gate and this is another OR gate.
Second.
I can apply A and B over here. This is A, this is B, and this OR operation output I can apply to this, and this I can apply to C. So that this will give me A plus B plus C. This will give me A plus B. Is it correct? Can I do this?
Yes, sir. Yes, sir.
So what I'm going to do, I'm going to use instead of this, I'm going to use such type of connection. So A and B I will apply to 1 OR gate, and the output of that I will apply to third OR gate with the third input. Got it? Okay.
Yes, sir.
So same thing I'm going to implement. How? The output of first is connected to input, output of second is connected to input, then the output of this OR gate is connected to what? Third, this second OR gate, and this output is also connected to this OR gate. I'll change the color of that. Let us say orange. This is also orange. Let us say this is all of you got how I made the connection, and then output of this I will show to the LED status. So this is the output 2. So what I will do, I'll connect a register over here. Output will be given to this register, and I'll connect a LED over here, and this is connected to ground. Let's check out whether this will work or not. Connection got? All of you got? Any doubt in this?
No, sir.
Okay, so let me take a snapshot of this and I will post it in my connection. Okay, this is a different one. Fifth experiment I copied and so this is the diagram. Now let's check out this one. So I'll correct this with the help of this manual. So input 0 0 0 0 0 1 0 1 0 0 1 1. So this is there. Okay, so if I don't use this, doesn't matter. I will make it 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So like this we can make. Then output at gate 1 AB, output at gate 1 which is AB, then output at gate 2 that is BC, output at gate 2 which is BC. After that I'll add a one column over here, insert column to the right, and, let me short it. This is output at gate 3 AC, gate 3 which is nothing but your AC. And this is output at gate 4 which is your actual output. Now let's check out what we'll get over here. So let's see in Tinkercad. Now let me simulate it. Okay, so I have copied that. Now let me simulate it, run simulation. So now all the inputs are 0 0 0, and I not checked what is the status at gate 1 and gate 2 and gate 3. So what I can do, I can connect LEDs like this over here in order to see the status. So I'll stop simulation. I'll copy this. I'll copy this. I have very less space available. Okay, what I will do, I will rotate it. This is one. I should have taken bigger breadboard. Leave it. This is 2 and another. I'll keep it. Third one, not an issue. I need 3 LEDs like this. So I'll copy that. I'll paste it over here. This is first. I'll connect it to ground. Right. I'll copy another. This. Yes. I'll paste it over here. Okay, and this is connected to ground. Black. I'll connect another third one. Just see, and if I'll let you know how what I have done just now. Okay, now this is input A, this is input B, and its output is this. So this connection I will connect to. I connect to. So I'll just I'll connect like this. Getting short of space. Okay, this will be better. So this is your AB output. Then B and C is going to this. B and C is going to this, and this is your this is BC. So this LED will show you BC, and then this last one, which is nothing but this. This is the last one. So that will okay. Now if the inputs are A 0 0 0, you are getting all zeros. Okay, all output as 0 0 0 0. Is it or not? Please let me know. All LEDs are off. Yes or no?
Yes, sir.
Now, if I apply 0 0 1, means C input is 1, others are 0. If C input is 1, this is C. If I make this as 1, what we are getting? 0 0 0 and 0. Yes?
Yes, sir.
So all the LED, all output are 0.
0.
Now, if the input is 0 1 0, means B is 1 and remaining is
0.
0. What will get? That will check. First of all, we'll make this as 0 and I'll make B as 1. Let's see what is the output.
0.
0 0 0 0, right?
Yes,
I'll make this all are 0. Now input A is 0 and B and C are 1 1. Input A is 0, B and C are 1 1. Look, this AB is 0, means first one is 0. BC is 1, so BC is 1. AC is 0, AC is 0, and this output LED is also on
1.
So this will be 1. Correct? Yes or no?
Yes, sir.
Next combination is 1 0 0, means A is 1, others are 0. A is 1 and others are 0. Okay, what is the LED status?
Off.
All off. So this is 0 0 0 0. Next input is A is 1, C is 1, B is 0. A is 1, C is 1, B is 0. What is the status?
0 0 1
LED is
1.
on.
0 0 1 1. 0 0 1 1. Correct? Next, A is 1, B is
Yes,
1,
sir.
C is 0. A is 1, B is 1, C is 0. What is the LED status?
1 0 0 1.
1 0 0 1.
1.
And last is all three are 1. All three are 1. What is the LED status?
1 1 1.
1 1 1 1. All of you got? Now just cross verify. Look, this is AB. this will be 1 whenever A, B are 1, 1. So these two are 1, these two are 1. That's why these are 1. And in this, all are, I mean, one of the bit is 0. That's why remaining bits are 0. Getting? Similarly, in BC, this is 1 and this is 1. When B and C are 1. In this AC, this and these bits are 1 when A and C bits are 1 simultaneously. Now let's cross verify this output 4, whether this is correct or not. How to cross verify? Let's go to this and just check out. Look, what is the status over here? 0, 0, 0, 1, 0, 0, 0, 1, 0, 111, 0, 111. Means proved? Yes or no?
Yes, sir.
Yes, sir.
So like this, by simplification also, we will be able to prove this SOP, that is sum of product form. Got it?
Yes, sir.
Yes?
Yes, sir.
And then resource used. In resource used, how to find out resource used? Just we'll go to the Tinkercad, we'll stop simulation, we'll take a print out of this. Okay, I'll take a snapshot of this and I'll paste it over here. This thing you have to mention over here. Can you? Yes or no?
Yes, sir.
Okay, now let's go to the PDF once again. So hence we have proved this experiment also. So resource used, just now I have pasted it. Actual procedure followed, you have to mention what procedure we have followed. Precaution followed, connection should be proper. Result, what you can mention, after simplifying the Boolean expression, also we are getting same output results. Then interpretation of results, simplification of sum of product will work. Okay, conclusion, simplification of Boolean expression reduces the hardware complexity. Okay, like that you can mention. Then define min term, so this already covered in previous lecture, so that you have to mention. Then what do you mean by canonical form? This also is available in previous lectures. Then explain significance of SOP, which is available in previous lecture as well as book as well as net. So that from there you can take out. Then standardize following Boolean expression. Now standardize means you have to convert this into its canonical form. So you have to convert it into canonical. So can you do it?
Yes, sir.
Okay, so we'll stop over here. So here we have completed experiment number 3 and 4. All of you have to submit this before next Friday.
Yes,
Got it?
sir.
Yes, sir.
Yes,
Okay.
sir.
Fine. So we'll stop over here and I will upload all these things maybe by today or tomorrow.
Sir, a
So
video.
if you have any queries, please ask. Tell me.
Sir, a video upload.
Video I will upload, but again that will take some time. Okay.
Yes, sir.
Any doubts other than that?
No, sir.
Okay, fine then. All of you can leave the session now and submit your assignment, means experiment number 3 and 4 before next week. I will create a classwork for that, and that you have to submit it. Okay. Do not upload this
Yes,
experiment
sir.
number 3 and 4 under experiment number 1 and 2. For 3 and 4, I will create separate link. Okay. Got it?
Okay, sir.
Yes, sir.
Fine. Thank you. All of you can leave the session now.